Today I'm going to demonstrate the pairwise comparison demo for the usage in your personal system. So we have the source code available on GitHub. So this link will provide the UI, which is made using Angular framework, and the other URL provides the backend, which is using the framework Springboot. So I have an empty folder. I'll clone this repository and I'll show you how to run this on your local system. So first I'll try with the backend. I'll just copy the URL and I'll clone this in my local system. So the front end has been cloned. Here we can see the front end. Now I'll clone the backend as well. Git clone, and I'll just copy the backend URL. And it's also cloned now. So to run this project you need an IDE. So I already have an IDE IntelliJ, and it's mandatory to have the Java version at least 11, and for Angular you required npm node as well as Angular CLI to be available on your personal laptop. So once you install both of these, you can start the project. I'll show you how to load the project. So this is my ID. I'll just go file, open. So since I have made this on my desktop, so here I can see the temp folder. So UI is the final project. So I'm using on the WebStorm. WebStorm is in one of the product of JetBrains, which is used for the UI applications. So I'm going to load this requested project and new window. So this is how you can load the UI, and the similar approach you can apply for the backend. So file, open, and then since it's in my desktop, so I'll go to my desktop, temp, it's going to take a minute or so to load the folder structure. Let's see. I think it's taking time. So anyway, the project, I already have it open on my laptop here. So once you open the project, you just click on this play button on the top on your IntelliJ IDE, and the similar approach we will follow for the Angular CLI. So I'll just stop my existing project which is already running, and since this is the first time you are loading this in your IDE, for UI you have to run npm install. Okay, in the terminal you have to run npm install. Once this is complete, you can just click on the play button and the project will start. So now we can see the backend is up and running on port 8081, and the front end is also running. It got started. So let's open the project. Localhost 4200. So here I can see the project got loaded successfully. So currently I don't have anything. It's by default the system comes with the root node. Now I will add few nodes on the system. So here, so let's add few nodes like okay. So as soon as I'll add a node, we can see in the UI in the tree map we have one node shown up. Now we'll add another B. Every time we'll add another node, the root will get further divided. So root was 100, now the 50 is given to A and another 50 is given to B. Let's see. We'll see the percentage get equally distributed among all three nodes, and their parent was root. And lastly, we'll add D. So here we have 4 nodes with equal values. Now we'll just analyze this value. For a sample, I'm going to provide some random inputs. 2, 3, let's say 4. I'll just compute the max inconsistency for this. So I can see the inconsistency I have is higher than the threshold. So my expected threshold should be 0.33, or it should be less than 0.33, but threshold is more than 0.67. So we can see it is on the inconsistency weighted chart how the inconsistency has been equally divided. So this is the highest inconsistent triad, 0.67, and these are the triad value 3, 1, 1, and these are the other triad value with their inconsistency values as well. We have histogram as well, and how it got plotted, so we can also see through histogram as well. So once we have this, we can just reduce the inconsistency. So the highest inconsistency element is 0.67 here, 0.67. We'll just click on the reduce inconsistency, and we can see that it has been reduced to 0.08, which is quite low. And we can just cross check in our pie chart as well as inconsistency reduction histogram. It has been reduced quite a lot. And the tree map updates their weight gets updated based on the inconsistency. So these are the new weight of the tree map. Let's talk about folder structure. So it's a typical Springboot folder structure where we have a loader which provides like the basic root node as soon as the application loads. So this REST configuration will provide the ID, the primary ID, expose the primary ID, and this Spring configuration, we have it for deleting the files which we can upload in the front end. So I'll show you how to do this as well. So if you want to load one of your model, so you have the option to upload the file. So assume like you don't have any file, so just click on it and you will download a sample. So since I already let's download once more. So let's open the file. So we already have some value, and let's add another row and another column. I'll just provide some random values. 2, and let's say 2 again. So you can put your values. This lower triangle values is like ignored because it's going to calculate based on the upper triangle again. So I'll save this. It's example 1. Let me choose the file. It's on the download. Example 1. The file uploaded successfully, and we can see there are 4 nodes created. Now we have like one node whose value is quite different. The node's new name gets created based on the unique ID. So I can change node name to D, and here I can see the name got changed, and here it also got reflected, and the updated value I can see it here. So I can calculate the inconsistency again. So this is the new inconsistency, which is 0.8, 0.7, 0.33, and so on. So I can reduce the inconsistency again using the same 0.27, and we can download the result as well. So I'll just download a sample result. So download, and we can have this, the new pairwise comparison matrix, and the tree map value also got updated. So yeah, let's discuss on the controller part of the pairwise comparison. So here we have all the lists, all the APIs. So the UI, the Angular will be hitting these APIs and getting the response, and then we have repository and the request response as well. So the business logic is written in this service part. So if you can see the pairwise service, the business logic, all the important code like how to find the triads, how to calculate inconsistency is covered in this file. So this is mainly the UI part we have. And then in front end, it's divided into different modules. So we have like about, charts, homepage, and model analysis. The most important part is model analysis. It contains all the important uh, code for creation of tree charts, and then pie chart and consistency chart, and calling the APIs. We have services here specifically for that. So currently I'm connected to my local system, so that's why I have a localhost 8081. One more important thing I want to tell in this video, we have an integrated database, H2 database. So I'll show you that. It's on, we can access that database on H2 8081/h2-console. So this should be the JDBC URL to access the database. We'll connect to database. There's only one table, node table, and we can see the values. So this value is the same value after calculating the inconsistency. So the value of node A is 45.99. The same we can see it here in the database. Okay, so that's all from my end.